Welcome to Spring LIB.
Our question says that we have a wire that is 4 meters long, so I write that here as L, and 6 millimeters in diameter, so I convert millimeters to meters, so that is the diameter D is 6 times 10 to the minus 3 meters. And it says this wire has a resistance R of 15 milliohms, which is 15 times 10 to the minus 3 ohms, and a potential difference of 23 volts. So our voltage V here is 23 volts, which is applied across the wire at each end. And it wants us to figure out for part A what the current in the wire is, for part B what the magnitude of the current density is, and for part C it wants us to calculate the resistivity of the wire material. And then using the information of the resistivity of the wire material, we can use table 26-1 to then identify the material for part D. Okay, so we have all our information written down here, so let's go ahead and start with part A, calculating the current. Well, to get the current, we can just simply use Ohm's law. So I, current, is equal to voltage over resistance. So you simply plug in the values above for voltage and resistance. This comes out to be 1.53 times 10 to the third amperes. We can box that in as our solution to A. For part B, we can calculate the current density, which is J, and that's equal to the current over the area. Well, we need to find the area. The area is simply pi r squared, where r is half the diameter, so this is equal to 1/4, because 1/2 squared is 1/4, pi times the diameter squared. Okay, so now we can plug this back into our expression for J. And J is equal to 4, because the 1/4 dividing by 1/4 is the same as multiplying by 4, so it's 4i divided by pi d squared. Okay, so we can plug in all of our values above and the value that we calculated for I in part A. And this comes out to be 5.41 times 10 to the 7th amperes per meter squared. Okay, and we can box that in as our solution for B. Now, part C wants us to find the resistivity of the wire, so let's go ahead and get a new page going here. Okay, so this is part C. And the resistivity, which we're going to denote as rho, is equal to the resistance times the area divided by the length. Well, we just had previously found the relationship for the area, so this is 1/4 pi d squared. So d squared, then the 4 goes on the bottom, multiplied that by the length L. So we plug in the values for R and D and L into this expression, and it comes out to be 10.6 times 10 to the minus 8, and the units here are ohms times meters. We can box it in as our solution for part C. Now, using this solution, we can look at the table 26-1 to figure out what material we're dealing with. And according to that table, this material is platinum. So we'll go ahead and write here, platinum. And we can simply box that in as our solution for part D.